Hello everybody, I'm here with another wonderful World of JTech video, and we have an interesting one here for you today. Basically, I'm going to be going over the basics of voltage drops on a circuit system. First off, we're going to make sure our vehicle power is on, which it obviously is. Double check, kill switch is engaged, and we're sitting here. Our code reader will sit there, test pass, no diagnostic trouble codes found. But as you can see, it will not crank. Well, this is a pretty interesting one. So as always, one of the first things to do is we have vehicle power is on. We check what our battery says. Have a multimeter set up. You can see it says 12.4748 volts, which is a little low, but it's not enough to help the engine not crank over. So next thing we're going to do is think to ourselves what would help, or what would make the truck not start. So like I said, we first off we think to ourselves what would help the engine. What would make the engine not fully crank over? Well, one of the first obvious signs once we have actually full battery power is we check the starter draw, and I have an amp clamp and digital multimeter already got and set up, and I'm gonna have my assistant crank over the engine real quick and read the drawing. Well, that fell a little bit, but I can see my amp clamp said about 650 amps, and I was getting a good 11.5 volts to the starter, so that's not the problem. So we start to figure out, once again, what would cause this problem. Well, we tested our starter. The draws were within tolerance. Now the other question we asked ourselves was, what would cause an engine to crank but not turn over? Well, we come over here and check our speed, timing, and reference sensor. Now the basics of any circuit drop identification is know what component you're talking about, trace the route out, and diagnose the system. It usually boils down to the sensor, the harness, or the ECM. There's a fault in one of them, either an open, a short, or a ground. Well, I come over here, identify my component, my STRS, disconnected it already, and hooked up my digital multimeter. You can see it says 13.45 volts. It's a little higher than battery, and I'm kind of curious as to why. So we'll go ahead and test out the rest of the circuit. When I come up here, start tracing it out by hand, making sure I have the correct components, and back to the ECM. That way I know which is the correct place to test. And here we are. Now I went ahead and got a circuit drawing, or excuse me, a circuit schematic of the speed timing sensor. Now these are not specific to location in the vehicle. It just says which connections happen where at both the sensor and the ECM. Well, as I just stated, I have here the circuit schematic for the STRS, and it's telling me that it should have pin connection at both 29 and number 1 at the ECM. Now I came over here and I went ahead and disconnected the ECM so I can test it out, make sure there's low resistance, as in no open or shorts in the circuit. And it's telling me I have 0.04, which is very good. Sorry about that. And as a quick test, make sure nothing else, switch over, and I have an OL. That means there's no continuity between those two wires. And just a second ago I was talking about the ohms in a circuit. A little bit ahead of myself. We're performing voltage drops. Now if you remember, when we tested the battery earlier, it was at 12.54 volts. If I hooked up the positive to the positive of the sensor harness to the positive of the battery, right now my multimeter is reading 12.1 volts. Alright, that's a 0.4 volt difference. It's not enough to be concerned about. Well, just a second ago I went ahead and switched around the leads from negative to negative, and once again our voltage drop is well within tolerance. Is 0.4 volts and holding steady. So the voltage drop across the STRS circuit seems to be pretty well within tolerance, and still not sure why the engine isn't cranking. We'll cover that in how we diagnose a circuit fault. Thank you. Have a good day.